Good evening, everyone. Thank you so much for being here. I truly appreciate your time and presence tonight. Allow me to introduce myself. I am Christian Ice, and it is my honor to present my research study entitled Effects of Flipped Learning with Gamification in the Mathematics Performance of Grade 7 Students. I'm excited to share with you the journey of this research, the insights we've gathered, and the opportunities it brings for improving students' learning. At this point, we all know that education looks very different compared to how it used to be. Before, face to face learning was the main way students were taught. But because of the internet and new technologies, there has been a major shift. More and more, teachers, students, and even parents are using technology not just in school, but also at home. This change has completely transformed how we think about education. Learning is no longer limited to the four walls of a classroom. As Delosier and Rhodes pointed out, the rise of online distance learning is one of the biggest changes in the history of education. It shows how powerful technology can be when it comes to improving the way we teach and learn. Together, we are living in a time of revolutionary change in education, and it's only just the beginning. According to the Chev and the Cheva, flipped learning is a flexible way of teaching that is becoming more popular today. In flipped learning, students use online materials to study lesson at home. This way, they can choose the best time for them to learn and really focus on understanding the lesson. Then, when they come to the class, they spend more time practicing and applying what they learn. Also, Cap and other authors said that the gamification is when we use fun game ideas in places like school, not just in real games. Gamification helps students feel more excited and happy to learn. Some examples of gamification are getting badges, seeing your rank in class, earning points, and being on the leaderboard. This makes learning more like a game, fun, challenging, and also rewarding. But even though many studies talk about how gamification makes students more excited to learn, there are not many studies that check if it really helps students to do better in school. Landers also said that the gamification doesn't change learning right away. Instead, it helps learning by making students more motivated and focused, which can lead to better results. Another popular way of teaching is called the flipped classroom. In a flipped classroom, students learn new lessons at home using videos or online materials. Then, when they come to class, they spend time solving problems and helping each other. And this way, class time is used for practicing and working together. And this research wants to help fill in what is missing. We will study how using flipped learning with gamification can help grade 7 students do better in math. We will also explain the ideas behind flipped learning and see how it can affect how well students perform. And the main goal of this study is to find out how flipped learning with gamification affects the math performance of the grade 7 students. Here are the study or statement of the problem. Number one is what is the mathematics performance of control group based on the pre and post test score? Number two, what is the mathematics performance of the experimental group based on the pre and post test score? Number three, is there any significant difference in mathematics performance between the control and experimental group in their pre-test score? Number four, is there any significant difference in mathematics performance between the pre and post-test score of a control group? Statement number five, is there any significant difference in the mathematics performance between the pre and post-test score of the experimental group? And finally, is there any significant difference in mathematics performance between the control and experimental group in their post-test scores? So let's see. Here is the methodology of our research. So the first is the participants. These are the grade 7 students of New Era High School, and we use the complete enumeration method. Also, to further identify the research instrument, this is a researcher made instrument. It consists of 50 item multiple choice tests, and also we have the pre and post test scores. For the statistical treatment, frequency and percentage distribution, we also use mean, independent sample t-test, paired sample t-test. Now we move on to the findings and the results of this study. In the first part, the mathematics performance of the control group. In the control group's pretest, out of 27 students, 22 students scored below average, and 5 students scored average. In the post-test, the results improved slightly. 13 students still scored below average, but 12 students moved to the average scores. However, 2 students scored poorly, and none of the students achieved above average or excellent scores in either pre and post-test. This suggests that despite some improvement, the control group's overall performance did not improve. Now, for the table number two, the Mathematics performance of the experimental groups. Table 2 shows that experimental group pre and post test scores. Out of the 27 students that completed the pre-test, 22 of them received scores between 11 and 20, which is below average, while 5 had scored between 21 and 30, which is average. 9 students had scored between 11 and 20, indicating they were below average. 17 students had scored between 31 and 40, indicating they were above average, while 1 student received a score between 31 and 40, indicating they were also above average. For the table number 3 shows that the difference between the control and the experimental group in their pre-test scores. The mean score for the control group is 17.15, while for the experimental group, it is slightly higher at 17.59. The total or the overall statistical analysis showed a p-value of 0.620, which is higher than the alpha level of 0.05. Therefore, the null hypothesis is not rejected. This suggests that there is no significant difference between the pre-test and post-test scores for both groups. In simple terms, both groups started with similar performance levels in mathematics. In the study of Makind and Yusuf, they observed that the distinction between the experimental and control group was minimal. This was evident from the mean score and standard deviation, which indicated that there was uniformity in the level of mathematics performance among all the students prior to the intervention. And table number 4 shows the difference between the pre and post-test means and standard deviation for the control group. The mean score in the pre-test increased from 17.15 to 18.81 in the post-test. The analysis showed a p-value of 0.172, which is higher than the significant level of 0.05. This means we do not reject the null hypothesis. In simple terms, there is no significant difference between the pre-test and post-test scores. The control group performance did not show a significant improvement from the pre-test to the post-test. For the table number 5, the mean score increased from 17.59 in the pre-test to 22.30 in the post-test. The analysis showed a p-value of less than 0.0001, which is much lower than the significance level of 0.05. This means the null hypothesis is not rejected. In other words, there is a significant difference between the pre and post-test scores for the experimental group. The experimental group showed a substantial improvement in their mathematical skills. And according to the post-test findings in table number 6, the experimental group performed better in math performance than the control group. The mean and the standard deviation for the control group were 5.66 and 18.81 respectively, indicating that they were below average. In the control group, the standard deviation was higher at 4.25 and the average mean score was 22.30. The total p-value for the statistical investigation was 0.14 or 0.014. The null hypothesis is rejected as there is significant difference between pre-test and post-test data. The experimental group seems to have begun significantly better than the control group since there was a significant difference in their performance. This shows that the intervention, the flipped learning with gamification, improved the experimental group's mathematical skills as indicated by a higher mean score and more consistent results. And for the recommendation of the study, it is suggested that teachers, school leaders, and coordinators, including flipped learning and with gamification, the grade 7 students, they should also hold more seminars and trainings to teach how to use interactive tools like EdPuzzle and other gamified elements such as a leaderboard, badges, and brain points. Also, we consider the challenges faced by students in far-flung areas. It is recommended that educational policymakers and stakeholders invest in improving technological infrastructure in these regions. This includes providing reliable internet access and necessary technological devices to ensure all the students have equal opportunities to benefit from flipped learning with gamification. Additionally, developing offline version of the pre-class learning resources and Gamified can help accommodate students with limited internet connectivity. It is a good idea for future research to make sure that the students have the same learning experience during experiments. Researchers should avoid changing how they teach during the study because different teaching methods can affect how students feel, how well they do in math, and even their happiness both in good and bad ways. By keeping the teaching method the same, the researchers can better see how flipped learning with gamification helps students in math. For future improvements, researchers should try testing flipped learning with gamification in other grades and subjects to see if it works well for everyone. They should also think about creating a training program for teachers to help them learn how to use these fun new teaching methods. Also, offering extra help like tutoring and more learning materials for students will make sure all students can enjoy and do well with this kind of learning. This will make school more fun and help students learn better. And for the final part, are my references for our study. And thank you so much for listening in our research presentation. I hope you learned something, and I would appreciate if you could learn or could share some insights and thoughts about this presentation. Thank you.